I'm going to show you two very different ways of solving this problem. First of all, this is how I did it. I said that L was the number of problems that Liz scored by herself, and then J was the number that they both solved. For they did jointly. So L plus J must equal 60 because they each solved 60 problems. And we can do exactly the same for Mary. The number of problems that Mary solved by herself plus the number they solved jointly is also going to equal 60. So let's just set up some equations. Now we've not actually incorporated the fact that they get 4 points if they're the first to solve, and if they're the second, then they get 1 point. But this allows us to write another equation down, and that is the Liz got L correct by herself, so she would have got 4 points in that situation. So 4L in total. The ones they both did, one of them would have got 4 and the other one 1. In total, 5. Okay, I'm just looking at the total number of points now. So 5J. And then Mary got 4 for the ones that she did. So if I add these up, then I'm going to get the 312. So I actually got like it's kind of a set of equations now, um, which we can go about trying to solve. So I could take these blue ones and first of all multiply them through. Like here's the thinking. We've got 4L here and 4M here, so I can cancel them out and then we're well on our way. So I can multiply the top and the bottom each by 4. So I've got 4L plus 4J is 240, and 4M plus 4J is also 240. If I add these together, then it's going to give 4L plus 8J plus 4M equals 480. All right, and this is actually where I want to be because I've got a simultaneous, I know I've kind of done strange things with simultaneous equations here, but it's working out. And now I can cancel out the M's and the L's. So if I minus the top one from the bottom one, then I'm going to get 3J. The L's are going to cancel. 8J minus 5J, 3J. The M's are going to cancel, and I've got 480 minus 312, which is going to give me 168. Therefore, J, I just need to divide through by 3. 3's into 16 go 5, remainder 1. 3's into 18 go 6. So 56 was solved by both of them. Method 2, very, very different. I, yeah, arguably it's definitely simpler because you didn't get simultaneous equations, but arguably I think it's a little bit harder to set up. But anyway, that's just what I think. So let x be the number solved jointly. Just going to use a general x now rather than m, l, and j. So that means that 60 minus x was solved just by Liz, and 60 minus x just by Mary. The reason being is that, again, they have to add to 60. Now, those that were solved jointly, 5 points would have been obtained overall. So I can write that down, 5x. Those that were solved just by Liz, she would have got 4 points for that. So it's going to be 4 times 60 minus x. And then just by Mary was also 4 times 60 minus x. So actually we can just double this one, and that must equal 312. So that's what I mean. This is much simpler because it's just simply got an equation in terms of x. But I don't know, conceptually I don't think this is obvious, but you might disagree with that. So now I've just got an equation for x to solve, so I can expand 5x plus 8 times 60 is 480, minus 8x is 312, and that is going to give me minus 3x is equal to 312 minus 480. I did similar over here. That's going to give me minus 168. And again, I get x equal 56. Okay, two nice approaches. Quite like this question. Well done.